Okay, so let me introduce our speaker today, Ramanan. So Ramanan is actually an SRE engineer from our TikTok team. Together with him, actually, I have Vernon in the background, but Vernon is unwell. However, he will try to support with the questions that you may have in the background. So I'll hand over to you, Ramanan, to introduce yourself as well as kicking off today's session. All right, thank you, Ramanan.
Thanks, Motomi. I'll just share my screen and I'll get started with my session.
Okay. Great. Yeah, your screen is good.
Okay, thanks. This slideshow. Okay, hi everyone. Thanks for joining today's session. So today we're going to talk about just a bit of intro to SRE, give a flavor of what SRE is, what we do as SRE engineers, and a bit insights into our daily jobs, day-to-day life, and a bit into technical aspects of SRE, what is observability, some discussions on where SRE like comes into picture, what is the role about, a bit deep dive into the roles. Yeah, so that's going to be the main talk of the day. About myself, I'm an SRE, site reliability engineer at TikTok. And my previous history, so I have like about 9 years of experience, worked with multiple companies, Meta, Amazon. So I worked with Circles Life and also with software consultancy before. And before landing on the SRE role, I have actually held multiple other roles in my past. So a couple of them were support engineering. One was again an SRE, and then also for a brief period, I was also a backend engineer. So uh, transitioning into multiple roles actually helped me land and grow, in the SRE sphere a lot better. So probably we'll go about that as well in the talk today. Uh, yeah, some personal insights about myself is like I've been in Singapore for about 3 years plus now. Feb 2020, just before COVID hit, I landed here. And before that, I was in India. So I've lived in multiple cities in India. You know, and personally, I like playing chess and Carnatic music. That's Indian classical. Okay, just reiterating about today's agenda. In particular, we're going to discuss about, we are going to start taking a journey from what you have already learned or what you have seen in the previous sessions. That is, how does the SLDC work, software development lifecycle, and then how does it transition into, when it's a small scale product, what happens when it's a larger scale product, what happens, and then what do particularly SREs do, uh, and a bit into observability, and then we'd probably take a break and then go through a bit of a small demo. It's not a huge demo. Then I'll share a couple of case studies where large scale systems had issues, and what does and a real work of an SRE in terms of deep dive look like, and then some personal experience. Okay, so I'm not able to see the folks, so I'll just call out, and if anyone has any answers, please put it in the chat. So this is the SL software development lifecycle. I understand most of you would have gone through this either theoretically or some practical experience would be there. So you have your basic set of ideas, set of steps that you usually take to develop a product. So let's say you don't have a product right now, you are starting to develop a product. You then, first gather your requirements, analyze your user base, analyze your business proposal, and then come up with a product proposal for it, which is then designed, and then it's implemented, and then it's tested, and then you release it to production, and there it forever gets maintained. So this cycle definitely uh, involves, your product teams, where your product managers come up with the ideas. They actually do the planning and analysis and then break down the idea into smaller chunks. And then comes your development engineering team, where designing the product, implementing the product comes into picture. And then your QA teams or testing teams, they test it, and then it's actually related to the release to the production, where a set of teams maintain it. So does this same life cycle apply to all kinds of scalabilities? So let's say uh, I start a product, it's at set zero, it's at state zero, and then 100 users come in, 1,000 users come in, 1,000,000 users come in. Now, in order to keep developing and keep launching new products, I have to kind of do the same. I had to go through the same life cycle, but my chunks are a lot smaller now. And the the features that I launch are, you know, much have to be a lot more tested. So as the product grows, you have less room for errors, basically. So which means as the product grows, you need to have multiple systems in place that either course correct your issues when your product is launched, or uh, some person or some team looking at your issues and then fixing them as and when they occur. So we're going to go into that. Just wanted to give you a flavor of what happens. So in your classroom projects, you are not dealing with users. Basically, you may be your own user, so you create a small product and then try to launch it, set up AWS instance, try to launch it, and you are basically the user, maybe 10 users. Let's go through what happens when you scale up a product. Okay, so another picture that I want to discuss as part of this is you have your idea phase, where your product teams come into picture. Your development team develops the product, it codes, you build the product, and you test the product. And then the process of putting a product onto production is called release. So you release a product where it's available for the users. Uh, so it's out in the open, anyone can interact with it. And let's say if you have some bugs, or let's say there is a sudden increase in interest, and your product kicks off, and then yesterday there were only 100 users using it. Today you have suddenly 100,000 users using it. So how do you manage the scale? What happens if that is the case? Does your product break? Does your do you have to look at something much more than just the product? Uh, is your product hosted well enough to cater to that particular scaled up user level? All these questions are much more than just the product, just developing the product or testing the product. So, sorry. In your previous sessions, you have gone through your backend, which is like, how do you develop the product? Testing, which is how do you test the product? Uh, but after releasing the product, how do you scale it up? Or how do you maintain that scale? How do you plan for scale? All that question is basically dealt with by SRE teams. Okay, so this diagram doesn't actually show the term SRE in it. I just wanted to give you a flavor of what DevOps means. So you have the dev phase where the product is developed, and then you have the ops phase where it is actually maintained. You deploy the product, you maintain it, you monitor for it, you monitor for errors. So this was what the case, a few years back, before the entire DevOps movement, where the development team doesn't usually cared about what happened to the product after launch, and the support and operations team did not have enough visibility into the product details. or they didn't have enough knowledge about the product to fix any issues that crept in. Uh, so this needed a different thought process. That's where the DevOps thing came in. And DevOps basically means development operations, where you ask the dev team to own up the quality of their product as well. And the support team actually knows a bit more about the product itself and has more ownership than just ticketing or something. So yeah, so just wanted to give you a flavor of what DevOps actually means, the term DevOps means. You have in the bottom, you have this big chunk which says on call. So usually in an engineering setup, everyone owns the product. So you have your engineers owning the product, you have your operations teams owning the product. So at the end, we all serve our customers. So, you end up taking on call in turns where you actually are the first point of contact for any critical issue. So if your product is going down, if some part of your product is going down, or there is a customer havoc created due to one of the errors or the bugs that crept into production, you are the person who gets the call. You are the person who needs to respond immediately and try to locate the bug and mitigate it as soon as possible. So that's what an on-call does. And it's usually throughout the uh, team, that is the engineering team, the support teams, as well as the SRE teams, which are part of the on-call and own the the primary mitigation tasks. Okay, let's move further now to understand about a bit of what is what is scaling up a product, or where do we come into picture, the SREs, and what is our main job. So it's like you launch a product. Now it has to be maintained. It can be a 0 to 1 product, which is the new launched product, or it can be a product which is actually in the growth phase, which is catering to millions and millions of users. So at any point in time, you will not have one of these two states. It's like a gradual state increase, which happens over time. So let's say you're a company ABC, and you have launched a product today, and you expect a 10% or 30% month-on-month user growth. Now, in order to cater to this growth, um, all you don't just look at your version of your product or the quality of your product. It's more about how do I launch the product. Now I had to host your product in some place, which is usually a virtual machine in cloud terms. And then let's say, so you host it in some machine. The machine has certain capabilities. It has certain amount of CPU, it has certain amount of memory, and each request to your application consumes some amount of CPU and some amount of memory. So which means as your users scale, uh, my CPU, my memory, and also my other requirements increase. Now, I cannot have a system which is like, manually every day. So today I suddenly see 100,000 users looking at my product. I cannot get notified after they start looking at it, because it's the opportunity that matters. So I need to be able to scale up my product at will, scale down my product at will, or establish a system which does that. Second thing is I need to be prepared for it. So I cannot be just looking at things ad hoc. Third is, let's say some natural disaster happens, I have a huge, let's say, my product is catering to millions of users. Let's say TikTok is having so many users. It's present in so many countries. And uh, today, or someday, there is a natural disaster in one of our data centers. Now what happens after that? Do we just say, okay, what can we do? The disaster actually broke everything in my data center. Should I just cry? No, I cannot do that. So I need to plan for disaster recovery. So, and also then I need to make sure my product is always up, because it has to cater to my users. So in each of these cases, 0 to 1 or 1 to millions, I have different problems that I'm dealing with. In the 0 to 1, I want to make sure that I'm open for more users to come in. So I plan according to that. In 1 to millions, I have a particular scale already established, and I have different problems now. So once I reach that level, I need to start looking at how to maintain that. I cannot be just wondering once the issue actually occurs, and then there's nothing I can do. So there are different issues that an SRE looks at different scales of the product. Now, okay, I think maybe it's an okay time to pause a bit, and I see some numbers in the chat.
Yeah, I think that works. Vernon is already typing
Okay.
for one of the questions, but I think the first one is quite straightforward for you, Ramanan. Maybe you want to attend that.
Okay. I don't have access to. Okay, it says, what is the difference between DevOps and SRE? Cool. So basically, DevOps is a concept which is having more development responsibilities. Sorry, having the devs own certain ops responsibilities, and having the ops own certain deep dives or certain insights into dev product. So it's like it's bringing them together to actually bridge that issue that I was talking about. SRE is more about, so you can say DevOps is like a class and SRE is like an implementation of the class, where SRE is actually a job function which caters to my DevOps principles. So DevOps is more like a principles, which is more theoretical in nature. SRE is actually the implementation of it, where I use the DevOps principles to develop CI/CD or deployment systems. I use the DevOps principles to make sure my product is always available. So we'll get to that in the later slides. Okay, so who does DevOps serve, and does the SWE team interact directly with DevOps? If yes, in what situations? Yeah, so DevOps has two major stakeholders, is what I will put it like. One is it serves the development teams to make sure the product can be pushed to production without any issues. So that's where it acts like a platform team. The second is it makes sure the product is always up and the users are happy. So that's where we also again act like a platform on the user side. So where we try to create tools or try to create feedback mechanisms to make sure the product is always available. We detect issues before the users report them. And so basically DevOps or SRE team serves two stakeholders, two major stakeholders. There are a wide variety of other stakeholders also. Does that answer the question?
Yes, I think very well. If they think they need like additional elaboration, they will type some more.
Got it.
Yeah.
Do SRE engineers at TikTok code or develop a lot, or is it mostly configuration tasks, manual tasks, toil 50-50? Yeah. So, from my description of SRE, I think you can guess that toil is a word which is definitely coined for SREs, and you will have ad hoc tasks because you're looking at monitoring a system where you're looking at system giving you issues. So a certain amount of your time does go on ad hoc tasks. I wouldn't say manual tasks or configuration tasks are, uh, that's not what you should be looking at mainly, because there are certain issues that uh, should be solved immediately. And you don't write a script, or you don't write a whole tool to solve something that can be solved manually in 10 minutes. So definitely there would be manual actions that you need to take, but it's usually at an engineering level and an engineering depth that you need to understand the system in depth, and that's the level of manual task that you're operating at. Configuration, yeah. So of course, when you are creating deployment pipelines, you do look into how do I configure things automatically. So there are configuration management systems that either you use or you create in-house, and so that's part of the process. In particular, in TikTok, definitely I would say during on call, I have a lot of manual alerts or tickets to address. But rest of my time, definitely I look at how do I automate things, how do I make life simpler, and that involves a lot of scripting and coding as well. So you'll have a good balance of looking at user issues, looking at system issues, and also looking at how to automate yourself out of the role and make sure you are available for larger issues to solve. So it may be 50-50 sometimes, it may not be 50-50 sometimes. So the ratio depends on how fast do you automate, how fast do you look at bigger issues. Yeah, the third one is not really related to this session. I think Motomi, you can direct them to other.
Yeah, sure.
Yeah, thanks.
Yeah. So for that question about like ML AI frameworks, I think Ramana is not the best person to take this. I will arrange to take this offline with you. All right.
Oh, I'll just take the last question and then I'll move on with the session.
Sure, I think that works. Thank you, Ramanan.
If SRE is not the one that codes, how does the SRE solve the bugs when error occurs? Okay, will there be a code or knowledge sharing between dev and SRE periodically? Okay, yeah. Um, Good question. And so I'll come to that in my one of my slides. Definitely, I'll just give a brief here. So in any system, you even the dev team doesn't code everything. If you are a developer, you'll at max code one particular feature or one particular user story in a feature. So that's the level of granularity that you're coding stuff as a developer. So even if you are a developer, you wouldn't know the larger picture. So doesn't matter if it's an SRE or a dev who codes the product as a whole. We create certain observability probes. So that's the reason where whenever you code, you emit metrics, you emit logs, and you emit traces, and these come as part of our observability discussion, and those give you insights into where actually the problem is located and what is the problem and how do we deal with it. Yeah, so I think that answers the question. Cool. Thanks for the questions. I'll move on now. Nice. Okay. I'll keep this view open because this is more convenient for me. So let's discuss about scaling and distributed systems a bit. Uh, any idea what a distributed systems is? You guys are college grads, must have heard this term. Anyone wants to answer just out of curiosity? Okay. No answers yet, but yeah.
Maybe
So
you can let them type into the chat. Anyone who wants to answer Ramanand's question, you can feel free to type into the chat. Multiple servers to do one task.
multiple servers to do one task. Okay.
Any other attempts?
Yeah. Okay. I think let's answer that. Let's go through this. No, not Kubernetes is just a tool. So we are dealing with concepts. So let's discuss the concept here. So um, it so let's say you have one API serving a particular function, and you have one system on which it's hosted on your laptop. Now let's say the laptop is not able to cater to the number of users, and you suddenly are seeing a surge in the number of users. You just replicate this same thing in a different machine, and then let's say uh, so you distribute the system to cater to a larger user base, and it's not just confined to one particular machine anymore. It's actually distributed across a wide variety of machines. You are catering to multiple design elements or multiple infra elements, including servers, databases, and each of them, or many of them, are not singular in nature. So they all are uh, replicated, or like they all have multiple hosts, and they are usually spread across the globe, or at least across a particular region or a continent, to cater to multiple users. So in terms of geography, it is distributed, of course. In terms of your application hosting, it's distributed because it's not confined to a single machine anymore. So you're actually dealing with a system which is having multiple branches. It's not like a huge bulky machine which is sitting in one place. It's actually multiple smaller machines which are sitting, you don't know where, it's sitting elsewhere, and it's catering to your users. Um, and when do you actually need a distributed system? So let's say, yeah, again, so it all comes back to scaling up of users. If you are scaling, if you just have a requirement for 10 users, you don't look for a distributed system. It's just a single machine, and that is more than enough to cater to your users, depending it yeah provided it has enough capacity. But so when you start moving and having more and more users, I think you move to a distributed system use case. And whenever things are branched out and has multiple replicas, and so things become more complex. And what are the usual challenges that you face? Yeah, we'll definitely come to this in the next slide. Uh, but I just wanted to call out and ask, what are the challenges that you usually expect in a distributed system? Any answers to that?
Anyone wants to, take a try? There's one in Q&A: synchronization, consistency.
Cool, nice. Okay, yeah, at least we got a few answers. Security, nice, cool. Nice answers, nice. So idempotency. Okay, so yeah, let's discuss some of these concepts in a later slide. But I think you're all in the right direction. Fault tolerance. And okay, so when we talk about distributing multiple systems and distributed systems scaling up, I just wanted to plug in this thought of microservices here. any of you guys know what microservices are, and how so are is microservices like mandatory for scaling up? Uh, is microservices mandatory for catering to millions of users? Any answers to that? Any thoughts?
They have done a little bit on microservices with
Yeah,
PyText.
yes. Yeah, that's the reason my question is here. You guys probably should have gone through this in. Okay, my process makes much easier, can scale the resources, can receive more load. Okay, got it.
Some more comments in Q&A. No, but it depends
Oh,
on the design of the program.
okay.
Yeah, breaking monolithic repo into smaller repos. Break a huge chunk of functionality into smaller multiple services. Example for better scalability.
Okay, cool. Yeah, these are all definitely um good answers, but they're not the reason why you should usually go for a microservice. Uh, okay. Yeah, one just tidbit here. Facebook is a monolith, and do you think at Facebook scale they require microservices? So definitely we're not looking at scalability as a problem here. Definitely, you can scale things as a monolith. You can just keep building things on the same repo. It just becomes a huge single repository. So the usual requirement for a microservices is when you want a distributed team. Uh, so when your team members are not able to handle so your product has become large enough that the team is not able to onboard onto it properly. You feel that you need to break things into smaller chunks and give it to each team separately so that they can take care of it better. I think those are all uh, the more relevant use cases why a microservices architecture works better. So it's usually that you can see a lot of products which are dealing with huge scale and which are monoliths. So the monolith versus microservices is not a strategy for just looking at breaking things down for scalability. So scalability is something you can also scale a monolith. That's not an issue. It's more dependent on how diverse your team is. Do you want to look at multiple languages? Do you want to look at onboarding the entire team onto the same set of problems, or do you want to break down your problems, break down your entire product, and give it to a different team? So it's more team dependent rather than the product scalability issue. Yeah. So let's move on. Just wanted to give you a, an insight into one simple distributed system, or you can even say, yeah. So these are some of the elements that you have in a system, in a software product. This is mainly from the infrastructure perspective. We are not looking at the product itself here in this discussion. So you have a product which is again, the nature of the product itself would be distributed here. So you have some API services which are hosted in a different set of containers, in a different set of hosts. You write up some RPC services which are hosted differently. Then in order to manage all of these, in order to manage the request to all of these, you have a load balancing system in place, and then you again have an API gateway in place to make sure things are routed properly. You can manage security as well a bit there. Um, and then on the bottom side of things, you have your databases. In order to serve your users better, you have cache layers. You have multiple other infra elements. You have messaging queues which are used for async So this can give you a picture of a distributed distributed infrastructure, distributed system itself. And just wanted to put in this in your mind in order to give you a flavor of what is the kind of infrastructure distribution that we are looking at here. And this need not be in just one particular region. So let's say I'm catering to Singapore and I'm catering to the US. Uh, I can have multiple services hosted in Singapore plus the US, which cater to my users differently. So at each layer, how do I manage my resources is a very big task. So let's say my Singapore TikTok users, so their request would probably go to a nearby server, which is probably hosted in, say, one of the nearby Singapore regions. And my US users, they all will hit my US servers. Now, each server would have their own databases in the backend, and the backend database have to be distributed as well, because you then have to cater to all the users. It's a global product. So what is available in Singapore in my feed should be available when I go to the US tomorrow. It cannot be that I don't have the data there. So my database needs to be distributed now. So I need to have multiple replicas of my database. I need to have multiple geographies in which the database are available. How do I sync between these geographies? How do I make sure data consistency is there, data availability is present? How do I uh, what is a trade-off that I make? Consistency, availability, partitioning. So there are multiple concepts that we actually deal with here in the entire infrastructure scenario, and all of these fall under the SRE sphere of action. So if you are an SRE, you are basically planning for a global product. How do I launch it globally? How do I make sure my data that is, I like a user in Singapore, it should be available to my Singapore user first, and it can be available to my US user later. It cannot be that, I like a Singapore based user, and then it reflects in my user US feeds, but not in my Singapore feeds. So, how do I manage this entire consistency or availability at a huge scale? So that's the problem that we are dealing with in our day-to-day lives. Okay, some concepts that I wanted to just bring to front. So these are also concepts that uh, you can keep in the back of your mind in case. So in case you are interested in all of these, maybe you're also interested in SRE as a role that you want to take up. So I just want to highlight a few of them so that we can discuss them. So capacity planning, again, as I said, if my product is in a growth phase, how do I plan for capacity? So there is almost every day, we encounter this issue of uh, capacity spiking up a lot, and then we need to add more capacity to our clusters, to our database clusters, to our service clusters. And how do we plan this in the long term? That is a challenge, because at TikTok scale, let's say there is some viral activity happening, which means you need that capacity for a very short time, and it has to work. So and later, once the virality has gone off, the capacity actually needs to go down. It cannot be up all the time, because otherwise you're wasting resources. So how do you make sure your cost is at the minimal? So you always optimize for your cost, and then how do you make sure your user impact is minimal? So it cannot be that my user is impacting, sorry, my user rate of usage is increasing exponentially, but my capacity is only increasing, maybe at a step by step or at ramp level at max. So is there a way I can plan for my capacity ahead of time? And that's an exercise that we usually do, where, not so like not just in TikTok. So it's a generic SRE phenomenon, where you plan for launch events or you plan for big days. Let's say you have a festival coming, or let's take example Amazon Prime. So let's say you have a Prime Day coming. You actually plan for the capacity that you expect on that day, and before the event, uh, you run a lot of load tests, you run a lot of disaster recovery tests, where you plug off a region, which means you switch off all the hosts in a particular region, which mimics the data center or that particular region going down, and you test if your application is still up. Is it able to cater to the level of users that you expect it to, or what is the gaps that you need to fill in? So capacity planning is a major task that happens at when your product is at scale. When it's small, you don't have to worry about it, because you're not going to expect either a user surge or you know a so it's not going to be like a sudden event that's happening. Or even if it happens, since it's small capacity, the capacity is usually available, you can plan for it relatively ad hoc. Yeah, and the second major area where an SRE contributes is availability. So you have this high availability system, which means I need to look for um, errors in my system which is impacting my users. So let's say due to some bug, my like button in my TikTok is not available, or like, yeah, the heart symbol is not available, or it's not working properly. So what happens next then? Which means my users are um, not able to like any videos, or like any comments. So it may look like, okay, what's in a like? Let's say 1,000 users are not able to like today, or today, right now. They can always like in half an hour, or they can always like in like tomorrow, the same video. But that sense of complacency is what we try to avoid, and we have that's our job, in order to not get into that mode of saying I don't care about my users. So it's always about caring about your users, and it's always about making sure each part of your application is available. So when we talk about high availability, we're not talking about TikTok itself going down. That would be a really major event where a lot of things have to go wrong to have for that to happen. So here we're talking about even small services that need to be up. So for example, this like, or comment or notification. So it cannot be that I like a user now, I like a comment now, and my notification is not delivered now. It gets delivered tomorrow. So that is not usually acceptable. And in order to maintain availability, you have a concept of SLAs, that is service level agreements. How do you do SLAs? How do you maintain SLAs? How do you detect breaches in SLAs? All of those are concepts which probably will also deal with in one of the later slides, or you will deal with them in the later session. I'll also try to give you resources on this offline after the event. That's okay. And the other keywords that are mentioned here are equally important, where if you are maintaining a DNS system, then that's your responsibility to make sure it's up. If you're using a third-party DNS system, then it's your job to make sure you contact them for any issues, and then uh, get the DNS thing up, because your application is not up. So everything boils down to system availability and anything that is going wrong. So even in terms of capacity planning, things like things like CPU 100% or memory 100%, basically that means your application is not catering to users, and that accounts to your availability issue. So basically, when you say survey site reliability engineer, you are looking for reliability there in the system. So reliability usually translates to availability. You are making sure your entire application is up. Yeah, I think it's a good pausing time to look at some of the questions. Is that okay?
Yes, of course, Ramanan.
Okay, so in the chat, there are just a few comments on monoliths. Yeah, cool. I'll look at the Q&A. How different components in the system coordinate together as one? Can I don't really like understand the essence of the question, because you will have multiple components in any system. So if you are developing, say, an application, you can have maybe a Python application. So if you are using the microservices approach, all you're dealing with is endpoints. All of these systems are black boxes where each system doesn't know what's inside of the other. So they all have these interfaces, application APIs, and any system just communicates with the other's APIs. So this works. So that's how systems coordinate with each other. And if you're looking at database coordination, again, it's very similar. So for behind every service, you'll usually have a database supporting it, uh, and it's usually a direct call to the database, and that's how things coordinate. Yeah, please feel free to ask if I'm not answered that. Different machines to work together to achieve a common goal. Yeah, I think this is answer to the distributed system thing. Scalability, because we can scale a single server instead of entire project. For horizontal scalability instead of vertical. Is this a question related to distributed systems, or because I see a question mark, but I don't see a question there?
It could be a response to your earlier question.
I think so.
Yeah.
How does TikTok managers keep morale of SREs engineers up, considering it feels like firefighting and little dev work, which can feel not as fulfilling? Okay. Again, as I said, right, even dev work may not feel fulfilling to you because you're looking at a very small. So at Facebook scale, I don't think you are going to work on Facebook entirely, or even at TikTok scale, you're not going to work at TikTok entirely. You are going to work on a 1% improvement of a notice getting delivered to the user. So this can be your user story that you're working on as a developer. So which means, uh, again, you're looking at a very small component when you're developing stuff, and it can be fulfilling for some people, it cannot be fulfilling for some people. But as a SRE, I get to work on systems as a whole. I don't care about individual. I mean, I don't have to nitpick and say this particular issue is what I can work on and I cannot touch something else. The entire TikTok product is my oyster, and I actually can pinpoint any team, why is something going wrong, fix this why is something not going right, fix that. Or I can be not firefighting, I can be proactive and say, tomorrow this is going to be your issue, fix this. Or in order to detect issues beforehand, you set up a lot of alerts, and where the system actually gives in a lot of feedback to you, and you become very proactive and try to mitigate issues rather than firefight them once they actually occur. So different roles have different fulfillment criteria, is what I would say. And SRE, as an SRE engineer, I'm pretty motivated to look at systems as a whole. How do I make sure TikTok entirely is up? And the scale of projects that I get to work on, maybe as a dev, you may not get to work on, but again, depends on what your role is, what your team does. So there are a lot of variables there, but definitely the morale is something that is really high in an SRE's day-to-day life. Okay, so the next question is, does TikTok implement shift left as part of its DevOps processes? By shift left, I assume developers owning a lot of production work, um, and it's usually taken care of by the on-call concept, where development team is also part of the on-call, and they feel the pain of the customer or the systems, and that's how that acts as a feedback loop to quality check their code or quality check their processes. Yeah. uh, in the case of an example given, like a user likes a post and the owner of the post has to receive a notification, would there be the use of mention would there be the issue mentioned in terms of delay of notification if the two actions were designed as an atomic transaction? Mm, yeah, so usually they are that is the problem, right? So let's say you like a notification, and it goes, so it's not an atomic transaction, like where the transaction gets completed and only then uh, you can move on, the user can move on. It's usually put in a queue or something where it gets processed at a later time in an async fashion, and that's the that's where how fast do you process your async, how big your queue should be, uh, and all of those issues come into picture, where you want to look at uh, you don't want things to get delayed, because the delay is not due to the database entry. The delay is usually because of, let's say, there is a viral video going on and a huge number of people are actually liking it, so which means there is a huge pileup in your async queue that happens, and then it takes a lot of time to process it. So the delay is in the second phase, so it's not a transaction that happens which gets recorded immediately. Could you explain again regarding your earlier question on whether microservices is mandatory to scale? Um, okay, so yeah, I was just coming to the point where as a monolith, you can definitely scale up. Uh, so it just takes a different approach to do that. As a microservice, we have seen cases where um, as the product scales, your network itself is not able to handle the load. So you get a lot of bottlenecks when you're trying to introduce multiple network calls, multiple services, and then each call actually it consumes certain network bandwidth or certain resources. So that acts as your constraint to improve your system. Let's say you in the other role where you have a big monolith, there is no network call that you're making. It's all internal, so it's all the same product, and you're not making a separate network call to call a different method. So it's just much more easier to, or it's usually much faster. And scaling that up would also not introduce these new issues where you're constrained by the infrastructure itself. So uh, microservices may not be the mandatory way to scale up a product. So it's more usually to cater to your team size and to grow your engineering team rather than grow your product. So you can definitely choose to have a monolith and then scale it up as big as you want, because even in the microservices sphere, you're not going to have an infra advantage over the monolith scale. So it can be as big as a monolith scaling up vertically or even horizontally. Yeah. I hope I answered the question. Feel free to ping me later. How to maximize the capacity? Does the system performance sacrifice when the capacity gets larger? Are there any way to mitigate the side effects if there are any? Again, coming back to the question on how, so it all depends on multiple variables, where you're trying to see what is the issue that you're trying to address here. So if you're trying to address a memory issue, definitely then you take a call on should things be horizontal scaling, should things be vertical scaling. And system performance is usually enhanced because of the scaling. That's the entire point of scaling your capacity. And again, at unforeseen, at so huge levels, you get to so you get unforeseen problems like the network problem that I mentioned, where at a small or a reasonable scale, you wouldn't even detect this as an issue because your network latency is pretty minimal. But when you're operating at such a large scale, your network latency actually contributes significantly. You're no longer able to maintain, say, 10 millisecond or 1 millisecond latency requirement. Uh, I'm just calling out random numbers. It may not be actuals, but yeah, just examples to that. In a general sense, system performance does get better. I think for this answer, one was typing. Okay, but I'm okay. He can answer. What kind of additional skill sets do SRE require as opposed to a normal developer? Yeah, usually it's a deep dive. So let's go to the next slides and then discuss that. I'll just take 2 more questions and later we can discuss other questions. For this one, I can answer in the next slides. Is SRE necessary for small early startups? In a small early startup, any engineer would do multiple tasks. So it's not very defined. Say a dev, I'll I'll just pick up a new task and then set up a deployment system, and I can set up an alerting system, and then I can also take on call. So in a small early stage startup, I am everything. And SRE is included in your dev activity because you don't have that much of a dev work to do. It's when you start focusing on large features, and that's when you then require somebody else to take up your ops activity, where somebody else is looking at scaling up the system, making sure I just have to write my code and build it properly. And this thing, I can just package it, give it to somebody, they'll take care of the rest of stuff so that I can go develop something new. So at an early stage startup, an SRE is not the first role that gets opened up, is what I'll say. But there are startups who like probably plan for the future and hire SREs as well. I'll just take one last and then move on. Could you elaborate on what are the ways to scale a monolithic architecture and what are the differences between scaling strategies used by monoliths and microservices? Uh, yeah, this is actually a good question. It's I I don't have a ready-made answer to this. And in terms of strategies, there aren't like a set of new terms that that are used for each of them. It's all vertical scaling and horizontal scaling, but it's just how you design your infrastructure is what matters. Even in monoliths, you can have you can have a distributed database system. So where your monolith is catering to, your services are catered to by smaller, you know, smaller capacity machines where, so even as a monolith, uh, how do I put it? You can develop tools which communicate internally effectively. So it can be hosted on a container. It can be hosted on a container which is large enough, but then I actually don't really. So I may have to read a bit more on whether the entire product is hosted on a single container, which is usually not the case. But in terms of terminology, there's no separate terminology for scaling up a monolith or a microservice. But this is a question which I can get back to you maybe after the call or in the next session. Yeah, let's move on. I'll take the rest of the questions uh, in the upcoming slide after these slides are over.
Sounds good.
Yeah. Okay. So cool. So this is a mind map which gives you some keywords that, as an SRE you usually look at. Don't get overwhelmed by this. These are definitely uh, these will be in your parlance when you start working even as a dev, or even a QA, because you're looking at systems as a whole rather than in parts. So when you look at systems as a whole, then each of these terms start making sense. And I'll just call out one or two important ones. I mean, all of them are important, but I just want to call out one or two which are used extensively in your day-to-day life. So you come across observability a lot. And observability usually cater to all of these keywords. So keep this mind map as a keyword mapping to your task. So when you want to do observability, you are looking at these issues: latency, traffic, error, saturation as the metrics. And then you have events, you have logs. And when you're looking at storage, you're looking at consistency, scalability, latency. So how do you manage latency? You use cache, you use multiple replicas. So then in scalability, what happens? You have replication, you have partitioning. So keep this handy, or like probably it's a good way to go through multiple concepts that you're looking at. And each concept you may require in your work as a software engineer. So don't look at it from a dev perspective or a QA perspective or an SRE perspective. At after say 3 or 4 years, you'll be well versed with most of these, because you're going to work as a software engineer and not just as a dev. um, so it, it's much more than coding. So even when you're coding, you need to keep in mind on how are you looking at each of them. What is your impact on each of them when it's deployed. So even when you're coding, you're not looking at your line of code. That is just one aspect of your coding. How does my code translate to my latency in my production, or making a DB call in this line of my code, how does that impact my overall database calls? How does that affect caching? Where do I need to set up my caching? How do I do logging? So yeah, just a mind map which I wanted to share here. Uh, okay, so here I just wanted to discuss a bit about cloud, what cloud does, and virtualization. How has it helped us in terms of looking at a distributed first approach, rather than having things on my local or things on prem and then trying to include service one by one. uh, Cloud computing has actually revamped your entire thought process about how you think about software development and software scaling. um, Mainly you have these three types of virtualization that is available in the market. Maybe there's a new one that has popped up which I don't know about, but you usually have virtual machines, which are just virtual replicas of your physical machines, which is also a physical machine somewhere which you don't know. And then you have a concept of a hypervisor, which is basically multiple operating systems working on the same machine to cater to multiple applications or multiple needs of your application. And the third one is containerization, which is uh, here, right, in the virtual machine space. If you don't have enough usage, basically you're wasting cost. And containerization actually solves for that problem. So each of these is a cost optimization on each other, or on the previous one. So virtual machine is actually so hypervisor is should be cost efficient than VM, and containers should be cost efficient than hypervisors. It can also go the other way depending on your use case, but usually the trajectory is this. And how do you use containers? All of these are different concepts that I just wanted to put in the slides so that you guys know what is relevant in the market, what is used in the industries. And nowadays, every company uses containers as their main infra elements. And if not for Kubernetes, you definitely have some other system in your infrastructure, which is again a containerized system. So Kubernetes is again it's open source, uh, which is adopted by Google and also by other uh, new companies. But if you look at Facebook, if you look at TikTok, they have their own versions of containerized infrastructure. But we definitely are on containers, and that's a concept that would be handy in your preparations, or in your software engineering career. Uh, and cloud computing basically is saying, so it started with the idea of how do I uh, you know democratize, or how do I make my computing available to all. But eventually you see that so since your computing is available now, which means your every other type of infrastructure element is also available, because computing is the base essence of everything. If you are able to make your CPU and RAM available to everyone, I think you can just make anything available on top of it. So cloud computing is what is the norm in the market. But definitely in cases where you need really high security or data privacy, you do go for on-premise setups. So let's say you're working in a banking sector where your data privacy for that country is very important. You try to not So either you strike a deal with your cloud provider saying, I need a private setup where my machine doesn't host anybody else's data, and you can dedicate that machine to me. Or else you go ahead and set up your own machines saying, I manage them, I set up all my network cables and everything. So uh, usually not the route taken by new companies, but that's also a possibility that you can take. Yeah. Okay. So to answer the question on what does an SRE actually do, this is a slide which I want to bring up. So basically, you are dealing with issues, and how do you then detect issues? That is a problem. And then how do you plan for issues? So these are the two major categories that an SRE deals with. I deal with, so as a product, I don't know what's inside the product. The product is a black box for me. So I need to set up multiple events in my product, which have to be emitted at, say, on a frequent basis, or whenever something happens, in order to know that that thing has happened correctly or not. So if I have, let's say there is a, I call an API and it gives me my profile. And let's say I call it one time, it gives me an error. I call it 5 times, it again, all the 5 times it gives me an error, which means there is a big, or rather, so from a user perspective, there is something wrong with the API and not with that particular moment of interaction. So if it was only like one time I call, there was an error, but the second time I call, it got rectified, things were okay. Those are usually not the issues that you want to look at, because a system at any scale, it can even be a new system, uh, can have errors because of unforeseen issues, or you don't even know what is going on. It can be like a network packet just got lost. So that can be an issue which you can never debug, or like which you can never diagnose or investigate properly. So once things start happening very frequently, then you use these metrics, or you use these event calls to deep dive into the system. So, for example, I ask a question. Let's say I have a server hosted in Singapore, which retrieves my, which is like, you use it, you go to your TikTok profile page, and then there's nothing written there. Now what is the, how do you debug this issue? So if you look at this as an interview question, definitely you would deal with this issue as on a day-to-day basis. So the interview questions are also designed to make sure you are able to perform the same thing in a day-to-day basis. So again, as a software engineer or an SRE, I encounter such issues on a day-to-day basis. So it doesn't bother me if my profile page is not available just once for one user, but it definitely bothers me if the profile pages is not available for 100 users or 1,000 or 10,000 users. So at what level do I start getting alerted for large scale issues? So that's what an on-call looks at. And how do I investigate into each of these? Is you develop tools for that. You develop debuggers, you develop your tracing mechanisms, where uh, you just have like a entire API graph which tells you where exactly the issue can be located. You develop your runbooks which say, this, if this is the error that you're encountering, do this. If this is the error you're encountering, do this. So it can be a manual investigation, where you go through your runbooks, you start looking at just hit and trial, say, what happens now? I just triggered this, what happens now? And then you take that approach, or else you have some kind of a tooling where you have a broader idea of the system and which helps you with investigating issues. The second kind of issues is whenever, and this is like the majority chunk of what happens in a day-to-day life, is the dev team pushes a code and which is faulty, or rather which has bugs, and suddenly once it goes into production, since the system is already catering to millions of users, the the bug just explodes and you get a whole lot of alerts from everywhere. Things are breaking in your production, and then you go in and either halt the release and roll back it, or else you do an immediate hotfix saying this particular variable is giving me null whenever this type of user enters, and you then write an exception which was not dealt with in the development phase, and then push it as a hotfix. So definitely you need pretty intense change management processes, pretty automated deployment systems, CI/CD, which is something which Vernon would also be talking about in his Wednesday session. So these are some issues that you are putting into the system. So by plugging in the SRE in the software development lifecycle and saying uh, what alerts do I need to set up for a new feature launch, that's where the SRE's contribution as a consultant comes into picture. So I'm not always ad hoc, whereby I look at issues only after they occur. I can be plugged into the development lifecycle where I work with the dev team or with the QA teams to make sure I am able to detect the unforeseen issues, which is not always testable, which is not, so you cannot have like all the edge cases resolved before while developing a product. There can be an edge case which you have never thought of, or which your team has never thought of, because your team is only 10 probably, but your users are in millions. So you'll have multiple permutations that you can not think on the development phase. So you can never do away with issues. There will always be issues because your input is limited, but your output, you'll always have unknown outputs. That's what I'm trying to say here. Okay, so let's probably pause here. Next, we want to go to observability. I'll take 3 minutes and answer the two questions that we have here. Okay. For microservices, is it still beneficial in terms of one service is down? It doesn't affect the microservices or system as a whole compared to a monolith setup, right? Yeah, so again, so this requires a larger discussion, which I may not be able to cover here. Even for a monolith, you can isolate portions of your product from each other uh, by by avoiding network calls, or so there's no concept of like, so you put in enough servers that things don't go down as a whole. So yeah, definitely a concept which is worth exploring. Good question though. Does TikTok use containerization like Docker? If it does, how is it used? Yeah, as I answered, it does use containerization, but not Docker. I don't know what it particularly uses. It's an in-house product. So we have our own data centers, we have our own infra teams which have used containerization concepts to set up our infrastructure. So containerization is the concept which is used. So when you ask how is it used, it's just a container. So you can imagine things just like how Docker is a container, like manager or like something similar. So it's again a container-based architecture is what I can say here. Thanks.
Over to you again, Ramanan.
Sure. Yeah. I hope everyone is back as well. Let me share my screen. Oops, sorry. Okay, let's deep dive a bit into observability. So yeah, so all of the conversation before this was regarding the role of SRE, what an SRE, what is the perspective of an SRE, and what do they actually try to achieve in their work. Now we are just tackling one particular aspect of an SRE's work and trying to see how do things work. So this is going to be so I cannot go into pretty like deep work here. So after this slide, I think we also have a demo. It's going to be a very short demo. I'll use just a few different tools that we can use, which are open source as well. And let's see how it goes. So observability is basically measuring your system from external outputs that the system gives. So the idea that I spoke to you in the slides before these, just an elaboration on that. So we want to know what is the internal state of a system. So let's say there is a report or an alert saying your service has been giving us, so 10% of the requests to your service are errors. Now your service is usually having all of those concepts of redundancy. So you'll not just have one host that is going that is hosting a service. You'll have multiple such hosts. Sometimes we have services large enough that actually use about hundred tens of thousands of containers. So when you're looking at so many number of hosts, 10% of your requests are going for errors, which means how do you locate which are the hosts that are causing the issue, or what is the reason these hosts are facing the issue and not the other ones. So how do you actually deep dive into my system? So my system needs an entry point, and then it also needs subsequent points which actually lead me to the final state of my final point of the issue. So observability kind of gives me the ability to know where the system is broken and when was it broken, how probably, yeah, how was it broken as well. So the second part of observability is I don't want to know if my system is, so let's say there's no prompt when there's an error. That is also an issue. So I will not be able to detect any issue unless the user gives me a customer service call and then reports that something is broken. So that should never be the case. So let's say I forget to set up some probes in my system, and which means that particular portion of the system is never going to give me any output, or like give me any metrics which will tell me that there is an issue, or there's a probable user impact that's going to happen. As part of the other side of things, I want to know whether the system is healthy or not. So by default, any system I would want to I won't want to just ping and see if it's up, ping and see if it's up. So I would set up, probes. So in Kubernetes, there are concepts for this, like liveness probe, or in a deployment, after deployment, you check for a readiness probe. So you want to make sure after every change your system is healthy, after, so which is after deployment, your system is healthy, and also after, during its running, if the system is healthy or not. So at any point in time, let's say your pod goes down or your cluster goes down, one of these probes which are external to the system actually fail. So from the external, I keep on pinging my system at frequent intervals to detect whether something is wrong or something is right. But this external ping is very limited. So it can only be limited up to my physical aspects, or the the infrastructural aspects to my system. But like from a functionality perspective, I may never be able to detect this. So from a functionality perspective, I need to make sure the system internally gives me some metrics or traces or logs which are able to tell me that there is particular issue going on. So I mentioned some related concepts that you guys may want to go through. So this entire idea of observability comes from control theory. That is, again, the definition speaks for itself. So you want to measure the internal states of a system and from its external outputs. So in control theory as well, you have everything as a black box, and then you give some inputs, you get some outputs, and then you detect what is the, based on your output, you detect what is the state of your system. So and again, as we mentioned, in SRE, the reliability word is usually associated with availability, and every move of ours goes into making sure the system is up at all times. So be it your disaster recovery, be it your capacity planning, or be it your alerting, or be it your deployments, everything would just converge on your system availability at any point in time. So uh, so observability also helps me to understand how do I optimize a particular system. So let's say I have every transaction, like every request logs my time that has taken to complete that request. So by this, I would actually know how much time was that request present in a particular service. So which is like the service, uh, uh, usually you have your turnaround times, which are recorded as latencies. um, then you look at your latency numbers. So let's say for this particular service, it started at this time, it ended at this time, so the latency is so much. And you kind of, so by getting these metrics, you know which systems are to be optimized if I want to optimize the entire system as a whole. So these observability metrics give me input into what areas should I actually go and put in my resources, put in my time, to make sure I improve the entire overall availability, maybe by an order. So, and the final thing, or rather the most important work that observability does is, whenever there's an issue, it should help me to detect things on a very fast pace, which is, I should not be waiting to go and deep dive into each component of mine. There can be as well, 5 or 10 or even 50 components. So I cannot be just going and looking at every single component and trying to figure out what the issue is when there is a severe fire that's breaking out. So the observability will give me that ability to detect things almost immediately. So in general, an SRE looks at all of these aspects, out of which observability, availability, incident response on call. So you kind of understand. So the CI CD is one area where I want to make sure the changes that come in are not causing trouble. So I want to make sure there is no manual changes that's going into the system. Uh, and the second aspect is observability, availability, incident response on call, which is like telling me that any ad hoc issues I'm able to detect and I'm able to cater to. Uh, so you can like look at it from these two angles, a role of the SRE. And there's of course a lot of other aspects that you look at. So I worked in teams where the SREs do a lot of user or like the user ticketing. So you can be an L3 support ticket uh, person. So where you are the first point of contact for before the ticket actually goes to engineering for any last level deep dives. But since you are the uh, owner of the production system, which means you know the engineering level details, that is the code access, you have the code access, you know how to read the code. So any system issues faced by the users which come as a customer call can be routed to you. So different teams employ SREs as different, like due to their malleable nature and due to their focus on maintaining the system's reliability, different teams have different requirements at a particular point in time. So it may not be the case that in all companies, in all teams, you have the same requirements. So some team may focus more on disaster recovery, some teams may focus more on setting up new alerts, some team may focus more on your user calls. Some of them can be pure tooling engineers where they help build tools to do load tests, you know. So I've been in such teams, so that's why I'm quoting those examples. So you can be a pure tooling engineer. So some of those questions which asked, does the SRE do actual coding work? Yes. So coding work does need not always mean you working on the product. Coding is coding, irrespective of what you code. And usually it's pretty high impact coding that you do as an SRE, uh, because you're looking at millions of users getting impacted. Preventing millions of users getting impacted, which means your code has to be of an equal or a much better quality than your product code. And it can be the case because you are detecting issues that the product code hasn't detected. So your code invariably has to meet the same or better standards. So if you're looking for a coding role, uh, I wouldn't discount SRE, because each of these requires a different coding skill set. And let's say you work on the CI/CD, that is continuous integration, continuous delivery. You learn a set of tools, or set of coding languages that cater to it. For you have entire companies for observability, incident response. So you have companies like Datadog, you have companies like New Relic, which do only observability. So they are like millions and billion-dollar companies which only do observability. You have company. So this PagerDuty is nothing but it's a product which can enable you to give a phone call. Like it gives you a pager. So incident response is where this thing comes in. So you have built an entire company just for incident response. You have Grafana, which caters to, it doesn't even do observability. It's just a dashboarding system where you can plug in a lot of data sources, and then you can see graphs. So it's a visualization company. You have GitHub, which which also does your repository. It also can cater to your CI/CD. Again, you have Jenkins, which is open source, which has CI/CD pipeline capabilities. Prometheus is entirely your metrics, infrastructure metrics. So Prometheus takes in your entire metrics that are emitted by your infrastructure, puts it so that acts like a data source, which can be actually used in your Grafana. So yeah, so you can see that each one of these items are basically huge companies that have been developed on top of it. So I've just given you a set of 6 names, but there are like if not hundreds, at least tens of companies that I can call out that are at significant scale doing this. So to actually bring back everything into perspective, SREs are in the middle of these two. So you push the devs uh, enough to maintain quality of their code, and you also push the support agents to make sure user impact is detected promptly. So SRE is like a middleman or like a manager and owner of these two, where we take care of product from a larger perspective and make sure we build systems that are at a larger scale, from a larger vision, rather, not a larger, need not be a larger scale. We just have a larger vision to things. That's what I'm trying to say. Okay, I'll just have a quick demo in terms of just to introduce you guys to a few of these tools. So okay, can so you do have so I have written down this set of instructions that you can just follow instead of my. So this is a GitHub repo which I just created. It's very basic code. You guys can take a look at. So instead of this, you can use your own code, your own application. It works the same. So feel free to test it out in your own applications. My objective of this demo is to introduce you to how do you set up, or rather setting up Kubernetes on your local machine. Um, you need not have a cloud access. So all of this demo is done on my local machine. And that's the reason I'm not also able to incorporate Elasticsearch in it, because it takes a lot of my system RAM and my laptop can crash. So I do not take the chance. So you can follow these set of commands to install Kubernetes, to install Prometheus and Grafana. And I've also given you the Logstash and Elasticsearch. So I can just quickly talk about what the demo is about. So the demo is nothing but, so this is just a dummy tool. So you can look at some image that you want to generate. I don't know if it works. Yeah, this is a third-party API. I think I used up the number of calls. It's not giving me anything. But yeah, as an alternative, I do have this anagram function, which generates all possible anagrams of any text that I search here. So this is just a tool which I deployed on Kubernetes. So you can follow the steps. You can set up a Minikube system on your local machine. Just this. So you can see that so here is one pod which is running for my machine, for my tool. And I've set up Prometheus and I've set up Grafana as well. So what Prometheus does is it takes the metrics from my Minikube system and pushes it as a data source. So to give you a bit of a insight, so when you do a minikube dashboard, so here you have the command, you start your minikube, then you have a dashboard. So this dashboard actually tells you how many pods you have, how many deployments you have, replica sets, stateful sets. So these are all Kubernetes concepts that you guys can go through separately. This demo should be able to give you the the keywords that you are looking at, uh, and here you're looking at multiple daemon sets. Prometheus has a daemon set. So these are the deployments that are gone in, but this is the first, this is the one that is the application deployment. um to be frank, this is not the ideal setup. Prometheus, Grafana, they all will have their own namespaces in a production setup. I just put them in a default namespace. Um, so just wanted to show how the graphs look like. So what you can do is, sorry for multiple NAs here. I think it will take a bit of time to reflect. So it's not able to detect that. So if you look at this, there is one pod that's been running, and here it says, what is my pod capacity? How many replicas do I have? What is the replica number of each of my deployments? How many nodes I have, since it's a single Kubernetes cluster that I'm running, it only has one node. How many pods are running in my system? So again, in my pods, how many containers? So it has the ability to give you much more than that. So just to give you a quick look into what Grafana is. So Grafana, again, as I said, is a dashboarding system. So you can actually have multiple such dashboards, and Grafana is again like a dashboard as a service kind of a thing, where you can generate your own JSON files, JSON dashboards, or you can go ahead and use your Grafana dashboards. You can just Google, and it can give you a set of Grafana dashboards that you can use. So you have pre-built Grafana dashboards. Uh, Sorry, I think, yeah, you can just Google the dashboard that you actually want. So for example, if you say Kubernetes Grafana dashboard, it will actually lead you to the particular dashboard that you want to choose. So you can go back to all dashboards and just start searching for the ones that you want. So if you want, say, if you're running a node application, yeah, so you can have a Node.js application dashboard, which will basically tell you how many process CPUs you have, event loop flags. So it's like a dashboard creation system. So imagine this, like you have a monitor with all of these dashboards running, and then it tells you, it blinks red whenever there is an issue. So for example, I I don't know if it will blink red here, but I can try to uh, kill one of these, or let me try and introduce maybe a bug somewhere. Okay. Mm, yeah, I don't want to mess this up right now. So okay, let's see. How can I? So okay, let me do one thing. Let me scale up because equals to 3. Deploy slash Tech Immersion. Oh, okay. Okay. think you can just go to the cheat sheet and it will say, okay, sorry, I'm missing the hyphens. Yeah. So now this is just going to, so if you do your get pods, you again see you have automatically scaled up this. So this scale function, so what I did was like a manual scaling, and you can create systems which do automatic scaling as well. So now if I refresh this, you see that the dashboard has the value 3, the graphs have shot up again, and from 16 it became 18 because it added 2 more hosts. So yeah, so just wanted to give this a flavor of what things look like. And all of this data is being pushed by your Prometheus servers. So your Prometheus pods basically, and you can actually look at your the targets that your Prometheus is looking at. So any unhealthy targets, it will bring it up. And if you click on all, you can actually look at the state of each of your targets, how it operates, and then let's say for some reason one of them becomes unhealthy, you can actually go ahead and set up alerts on top of it. So Grafana also gives you the ability to set up alerts. Yeah. uh, Sorry, you do an explore. Yeah, so here you can actually use multiple data sources. You can type in your metrics query to look at multiple infra, metrics, and definitely you can go ahead and create an alert which says if this particular metric goes beyond a certain threshold, uh, send me an alert. So yeah, here it says, so which is my function, which is my input. Basically these are the inputs, and you set thresholds. You say a is above 5 or 10, depending on what is your metric that you're looking at. And then you can actually do a preview and add query. It will send you an alert to whatever third party app or first party app if you're creating one. So you can actually integrate your Slack here, integrate your Lark here, which is a TikTok tool. And again, it gives you the ability to detect issues before the user actually reports. So yeah, this was just a quick demo on how things look. What are the different panels probably you can look at? What are the different tools you can look at? Yeah, I'll go back to the presentation. Okay, so here are a few case studies that I just wanted to refer here. So one is from Google and another is from Facebook. So Google actually, once before they were actually onboarding Yahoo as their client, their indexing failed, and it looks like the issue was not at a software level. So the hardware was what causing the issue. And it's like the hardware disks, they were spinning in a uh, different pace, and that's what was not enabling it to write to the hardware. And that was detected after doing a thorough debugging into the software and making sure the software is not the cause of things. So as an SRE, I think there can be a case, since your job is to do debugging, and if you really enjoy it, you have scope to debug at a very uh, granular level, which also enhances your technical skills. So it gives you the ability to learn things pretty conceptually and become a master at things with a wide variety. I don't think as a developer you'll get an opportunity to look at the computer hardware. It will be very rare. As an SRE, there are data center issues pretty often, and you look at your data center lags, what's going on in the sync ups, like the data syncs between data centers, or so you have the opportunity much more to look at issues which you would never look at otherwise. So you'll get that larger scope and a larger frame of mind to work on a software product as a whole. Yeah. So tomorrow, if you're working, if you're starting your own company, you'll know what to expect rather than to figure it out on the go. And the second case study was from Facebook. Again, they didn't want to move to microservices because of the speed at which they wanted to scale their product. So again, as we discussed, the reason is not due to scalability. The reason was, how do you want to architect your engineering teams? At what pace do you want to move? So usually there can be a case where, if you break things down in microservice, uh, you may think that things move faster, but here is a case study which tells you otherwise. So definitely worth reading these two case studies. Please go through them whenever you find time. Oops, sorry. Yeah, so I just wanted to share some personal experience before which I can also take a few questions. But yeah, let me just complete this. I think I only have this one slide. So I've worked in 4 different companies in my career, and TikTok definitely is one of the best works that I have been doing. So I've been in TikTok for about 8 months now, and it's definitely the challenge is at a really higher level than in my previous jobs, and I do find things pretty open, and I'm able to contribute at a larger scale. So in my previous roles, I've been a support engineer in Amazon, and I've been an enterprise support in Facebook. So in both of those roles, you definitely look at customer issues at really large scale. So I was particularly in the Audible team in Amazon, and then we used to get issues um, relating to so that was an individual customer product. So it was a B2C product, and let's say you have like 10 customers reporting the same issue. That's when it was considered worthy of an L3 issue. It was considered actually a large scale, or like a serious issue, not a large scale. It's and we used to assign a higher priority to it. So but when it comes to multiple other companies, maybe 10 customers is not the benchmark. You may have 1,000 customers as the benchmark. So at what scale do you look at customer obsession is again depending on the company that you work on. So there's a tool that we develop called debuggers, which does what an SRE or a support engineer does manually. So basically, a debugger is like a transaction analysis or a deep dive tool. So it follows the steps that you would follow otherwise, uh, like following a run book or something, and it tries to detect an issue, whether it's your ownership or not, whether that issue is solvable or not. So if it's solvable, then you probably can assign it to a bot which takes action automatically, or it calls up the on call and says this is not solvable by the bot, take action on it manually. So I've worked on debugger tools which impact the entire customer service of say audible, and it just by creating one simple tool, you are able to eliminate the pain of multiple teams, which actually translate to millions of customers. So don't look at things just from like a one simple tool perspective. The cascading effect is pretty huge there. Uh, so the tool itself may not be used by millions of people, but the pain that you're relieving is actually millions of people's worth. So that was like one example which I can give by debuggers. And in alarms and monitoring, like in TikTok scale, we have you know so basically you set up an alert at every node, or at an every service event you get some alert. So at TikTok scale you have like tens of thousands of alerts, and how do you manage them? How do you take care of each one of them? How do you make sure your on call is at his or her peak efficiency? So all of that takes very serious digging into your alarm numbers, into your product. How do you say this particular alert has this user impact and this significance? So this is, a product, a problem by itself which you need to solve. And let's say if you're a budding company, you may not have hundreds or thousands of alerts, but at TikTok scale or at any large company scale, you need to make sure you're not overwhelmed with them. So again, at scale, you start to have multiple other problems. And in general, you do a lot of tooling to say alleviate on calls pain. So let's say you have a issue that's going on, a customer is not able to puts in a keyword or a customer ID or something, where you're able to retrieve multiple information relevant to the customer, which will be able to help you debug the issue. So you create multiple innovative tools that help you resolve the issue at the quickest possible time. So an SRE role gives you that opportunity to be very innovative, not just follow the footsteps of your product management teams. So yeah, I'm just trying to make the point that NSR is a lucrative role that you guys should also be able to pursue. And it's not something that is, boring or dull. So it's actually pretty exciting when it comes to day-to-day work. Yeah, so these were some experiences that I wanted to share. Any questions that you guys have? Your assignment will be shared later. Yeah, thanks. And any questions that you guys have?